This lecture is a special lecture to give you an example for the term project. We discussed the objective of this course at the beginning of this course, that we want students can apply the knowledge of hydrology to solve the problem in your region or your hometown, and you can pick up the problem from your area or your target area. For example, the drought problem and flood problem in your area, and apply the hydrology knowledge to solve this problem. So this lecture introduced the example of the drought problem. Okay. And this example the problem is we want to find water for sugarcane in this area. This target area is the area in the Ampere Pochet and Surin province. The area is about 1,300 right, okay, for the Surin company. Yeah, they want to find water for the sugarcane plantation. So this picture show the target area. You can look at the background is the photo area photo map, okay, and for the green color is the plot or the area of the sugarcane plantation is about 1,300 square 1,300 light. See in this one is square, this one is mean that just the plot area for each plot, okay, and the white color is the contour line. You can look at there is the number show that the elevation of this contour line, but from this data we can't use this contour line to imagine that how what is the shape of the area, which one is the the lowest one, and which one is which area is the highest area. So it's difficult to identify the characteristic of this area using this contour line, because it's not very large for us to, we have to do another way to find the contour line, okay. And this figure show we can, if the topographic map is scale 1 to 15,000 available, we can plot this area into this map. This area is about 2 square kilometer, and we can look at on the left hand side of this area is a stream, stream. Another side on the right hand side is a stream, another stream. So we can say that, imagine that this plan should be on the upstream water, upstream area, and water flow from to the west and east of this area. This is just to expand, enlarge this area. The other thing that you can see that is the contour line on this area as well. 2,000, and this is spot height to 202. So 200 is, because contour line is very rough, the contour interval is about 20 meter, or even smaller is like 10 meter. So it's difficult to, we can't see anything from this rough contour interval. Okay, this is the green spot is the existing pond in this area. So we have to utilize or use this pond for our project as well. Okay, so we have to buy the data from the development department. Okay, sorry, it's not in English. So it's a scale 1 to 4,000. So it's a very small area, small maps, and for the digital elevation model is 5 times 5 meter and contour interval 2 meter. Okay, and when we got this information, we can plot the new contour line. Okay, so we can see that it's more clear that this is the top area, the high elevation area, and we can see that we can divide that area in based on the watershed dividing. We can say that this is like the dividing catchment is like water flow up and down based on this contour, based on this catchment dividing. Okay, water flow like this. Okay, and this more another view. We plot the contour line on the area photo map, and finally we can divide. We can draw the subcatchment dividing based on the dash green line. The green line is the subcatchment dividing. Okay, and in this case we divided the whole area into 5 subcatchment, and we locate the pond area at A1, A2, A3, and A4 and 5. So that is the pond area. Pond location is depend on the existing pond as well. Okay, and we can so we can know the location of the pond, the appropriate location of the pond, and the area of the subcatchment area of rainfall come to this pond. Okay. And the next we so this is look at the area of each pond, each area of each subcatchment. Okay, and we found one thing that for the A4 and the south of the southern part of the area, there is water come from outside passing through this area. Okay, this one we can show that they found it at A4. Not only the rain surface water from the target area, but some part of water come from outside. So this is part of water come from. Okay, some part of water from outside of the target area is passing through this A4 as well. So we can collect more water, not just only the water inside the target, but outside is also passed to this area. That is at our advantage. Okay. Next step, we have to evaluate the runoff from this area. The first thing we have to find what from the rain gauge. Okay, so this location of the target area is on somewhere here. Okay, so we expect that the nearest station is Sangka station, and 27 is mean the location of the stream flow. So we have to use rainfall from Sangka and stream gauge, stream flow data from number 27. So for the range is for the Sangka station, it's about annual rainfall average is 1,200 millimeter. But for the stream flow at the station number 7, we can look at the table from the EGAT report. Okay, number 7 found that is a Ban Pon Chai, the M102 at the area drainage area 207, and annual runoff is above 58.8 million cubic meter, and on average is about intermediate is 9.0 lit per second per square meter. So we can use the annual flow to estimate the runoff to our subcatchment. Okay, so from the annual runoff 58 million, so we convert to cubic meter, and divided by the area is mean square meter, and time 1000, so we get the annual yield runoff is about 254 millimeter per year. We can divide it divided by rainfall, so we got the what we call the runoff coefficient, or the factor that rainfall convert to runoff, is about 23%. So it means the other part is infiltration and evaporation, so it's difficult to measure. So now we know that the rainfall convert to runoff just only 25%. So we can use this ratio to find the runoff in our area, target area. Okay, for example, for the A1 is the area is 0.88 square meter. We can convert to square meter, cubic meter. Okay, and multiply by the rainfall 1.215. Okay, and multiply by the factor to up 23%. So we got it around this number. Okay, so we can estimate the potential surface runoff to our area. Okay, totally for in this area is about 0.6 million. Okay, from target area, but from including outside is about 1 million cubic meter of the surface water. And the next we do what is our demand. So from we know information that they say that the demand for the sugarcane is about 450 cubic meter per light. So we know that about 1,300 lights. So it means that we want the demand of water is about 390,000, about 0.6 million. And you can see that from the estimate surface runoff from rainfall is about the same scale, about 0.6. That is but that is on average of rainfall. Once we face during the dry year, so we can expect that the water will less than this number, and we have to reduce the size of the area. The question is, how can we collect the 0.6 million cubic meter if we make a pond about 6 meters? So we have to use this area about 70 right. Okay, so it depends on the policy of the owner or the vision of the owner. How can we correct? If we want to collect surface water, we have to lost some part of the land for water. And this table you have done already from the lecture 7 to estimate the water requirement from the sugarcane. That is from the crop water reference. This one, the first row, it means from crop water reference is about a millimeter per year, and we multiply by the crop factor, soil factor, and can estimate the actual evapotranspiration, and from subtract the rainfall. Monthly rainfall, we got the irrigated water demand. So we got like for the sugarcane is about 3 millimeter 60 millimeter, okay, or about 900 cubic meter. So we can say that based on the crop water requirement, we can estimate the irrigated water for sugarcane is about 9 cubic meter per light. Okay, that is like the conflict between this, because maybe it depends on the climatic condition. Okay, but we can, for safety, we can use the 900 cubic meter per light. And this table we can estimate the for each the subcatchment. We can develop the pond for each subcatchment. So this is existing. So this is existing. Existing size of the pond, and we can say that is the maximum. This one is the maximum storage, and we can increase this one is the we can increase storage unto this one for this number. Okay, for example A1, we can existing storage about 15,000, we can increase to about 228,000. Okay, this recommendation for the owner to develop the pond to collect water for sugarcane. This final is the master plan for surface water development for this sugarcane plantation in Bochet, Turin. Okay, so we can see that we have the A1, A2, A3, A4, and A5. Okay, the pond area is 5 location, and we propose the location of the pond and the embankment. You can look at this. This is the embankment. Okay, so if we dig the soil from the pond, so we have access the soil, we can make the embankment and to correct the water, to control the water flow to the pond. Otherwise, it's passing through this area. So, okay, that is I hope you can learn from this example and develop your own project based on your context from your area and your problem. You can work together in the groups and identify the project and try to solve the drought problem for your area, for community water supply, or for any crop in your area.